Good morning. Today's panel will be run by TBW Advisors LLC Chief of Research, Dr. Doreen Galley. Dr. Doreen Galley has 6 degrees, including a Waterloo CS PhD in SIMD data storage and 8 patents held by IBM, with 2 more pending at Microsoft. She has led significant and measurable changes at IBM, DPWN, Dell, AT&T, and most recently Microsoft, where she was the platform architect for Azure and CTO of Azure's MCI She was trained as an analyst by Gartner, where she was recognized as an expert in all things data, from ingestion, quality, governance, integration, management, and all forms of and analytics, including sensor data. An All-American athlete, collegiate runner, woman after my own heart, Dr. enhanced her formal education with process improvement certifications of Black Belt, Lean Six Sigma, and pole thinking, along with technology and network transformation certifications from AT&T. She is a top 25 women on the web recipient and is a published author of over 200 articles. Her first book, Distributed Operating Systems, was published by Prentice Hall in English and Chinese. Her second book, Galley's Key to Success: Optimize Your College Career, is available via online bookstores. Dr. Galley has been an invited speaker at such distinguished venues such as Forbes Executive Summit, CIO Academy, Grace Hopper, Network Plus, Interop Las Vegas, Gartner's Catalyst, as well as the Internet Security Conference. Please welcome TBW Advisors Chief of Research, Dr. Doreen Galley.
The number of AI users globally grew from 159 million in 2020 to an expected 729 million users in 2030, according to Statistica. Global generative AI market is currently at 44.89 billion, according to Exploding Topics. By 2030, generative AI market alone is expected to reach 25.7 trillion, contributing to a 25% increase in global GDP, according to Enterprise Apps Today. McKinsey estimates that deep learning techniques can provide an addition value ranging from 30% to 128% beyond traditional analytics, depending on the industry. Furthermore, generative AI is now adopted by 92% of Fortune 500 firms and are highlighting its wide impact, according to Exploding Topics. Welcome to Industry Whispers, Deep Learning and Generative AI in Production, an engineering panel, research code TBW 2045, held May 24th, 2024. For today's session, we'll do a quick AI orientation. I'll introduce our speakers and give them the first topic, and then we'll return to the general Q&A, followed by brief announcements at the very end. So generative AI, what is it? What is it? What is AI? ML is machine learning. It's the ability for the computer to identify patterns without human intervention. Behind the scenes, it's a lot of multivariate algebra. NLP stands for artificial intelligence, dealing with natural language processing. That's when you can understand, interpret, and create human language. Large language models is the basis for generative AI, and it's a type of machine learning model and a subset of natural language processing. It involves text prediction, generation, and sentiment analysis. And of course, it's a form of deep learning. Deep learning means that it learns as it operates, as opposed to being programmed. So large language models versus other deep learning. All deep learning is about neural networks. For large language models, they have self-attention mechanisms, which allows them to be contextual. CNNs, or convolutional neural networks, are used for image processing, so we'll see some of those, and deal with spatial hierarchies and local features. RNNs are for time series data. That's the type of data you get from Internet of Things and machines or networks. Sensor data, it deals with recurrent connections and it's sequential. But since it's sequential, it limits its ability to achieve parallelization. In terms of types of large language models, or models in general, you have your pre-trained models, which is generic, trained over vast amounts of data, has your general knowledge and semantics. But if you take that general model and you fine-tune it for a specific task, then you have a fine-tuned model. But today we will be dealing with a lot of multimodal models. That means it's not just about text. We got some video, we have some audio, we have all types of forms. So with that, let's dive into our first panelist. He's the head of AI for Pixellot. We first met Pixellot during our coverage of the NAB show in April. Pixellot streams 10,000 sporting events every day of all types of sports. So Omer Segal is the head of AI at Pixellot, and he oversees the AI group responsible for researching and developing of automated sports production and automatic game highlights generation for Pixellot AI-automated sports camera systems. His extensive leadership experience in CTO and R&D Director at companies homeland security, mapping, and sports technology, where he oversaw the development of innovative AI applications. Omer's project portfolio includes creating land vehicles and aerial mapping, and navigation systems, AR applications for archaeological reconstructions, and athletes video analysis applications. Omer holds a BSc and MSc in electrical engineering from Tel Aviv University, specializing in the application of advanced technologies such as deep learning and computer vision and signal processing. So Pixellot does a lot of sports streaming. Some of you might naively think, I could just do that on my phone. So Omer, in addition to introducing yourself and how you apply generative AI and deep learning for sports coverage, could you share what you do at Pixellot and why does sports streaming require deep learning and generative AI and a multitude of AI and automation techniques?
Thanks, Doreen. So, hi, it's great to be here, first of all. Thank you for having me. Let's start with what we do actually at Pixellot. So, we produce sport events in a completely automated process, from the AI camera on the field to the viewer at home. So our system includes a camera set alongside a computation device with GPU, etc. And the system is installed at the field and captures the entire field all the time, like we see here in the frame. So we see here, for example, a wide frame that includes the entire field. And if we would broadcast this frame all the time, it would be a pretty bad production, right? Pretty boring. So what we do is we want to make sure that we don't want to capture the entire field. We want to capture only what is interesting, and that's the key part here. Our AI on the edge understand the dynamic in the event and decide what is interesting to be broadcasted to the viewer in real time. So we see here that we have these rectangles on top of the frame that indicates what was actually chosen to be broadcasted to the viewer, and the viewer doesn't even aware that actually it was rendered from this full view field. So the way that we produce a stream is supposed to be just like a TV production without anyone in the loop. And this is pretty challenging. So like you said, Doreen, we have a large scale on production with many sport types all over the world, from soccer, football, rugby, football, field hockey, baseball, lacrosse, handball, and the list goes on. And just to get a bit of the challenges that we have, a professional cameraman, a human cameraman that produces football, for example, might have trouble producing a soccer event or a basketball one because it's a different game, different production behavior, it's a different expertise. And our AI needs to master all of these. Yeah, so this is challenging for itself. And on top of this, this automated production, we also take the production videos that we create and the data that we extracted from it when we process the video for the production, and we create analytics and we create highlight clips. And that's a very interesting domain and a challenging one, as well, that generative AI models has a lot of benefits here and can take it to the next level. So if we can go back to the question that you raised.
Yes, the question is, could you share why sports streaming requires deep learning and generative AI and a multitude of AI and automation techniques?
So if we look on the challenges that we have, some of them I listed. We need to run in real time. We need to run on the edge with limited computation resources. We need to support multiple sport types, and to create a fully automated TV-like production, and all of this with large scale on production. Yeah, so all of these challenges, actually, when we try to think about it today, it's even difficult to imagine how you could have done it without using deep learning models. So to create a TV production without anyone guessing that it wasn't produced manually, it's very complex. The production should be smooth and has a natural movement. It should zoom in on the action in some cases, and it needs to zoom out if the play requires it, because sport is a very dynamic, it has a very dynamic scenes. And also, we're talking about an environment that has lots of interferences and noise, and the AI needs to handle all of these without being confused. So that's why these models are such a crucial part from our production.
Excellent. Thank you so much. I don't think we'll ever look at a streaming sport event the same. When you think about analyzing all the complexities, that's fantastic. So at this point, I'd like to introduce Juan Carlos Leon from Zero Space. We first met Juan in Zero Space at our coverage during NAB show, where they displayed their ability to do motion capture, but no one has to put on a special suit. You just set up the space to do it. Really fascinating. With 20 years of experience as a character technical director, Juan brings expertise in motion capture and avatar creation for diverse productions. Originally focused on rigging for films, commercials, and games, Juan transitioned to real-time motion capture and game engine rigging over the past 5 years. Integrating AI into motion capture and avatar systems has been a recent passion, along with the commitment to explore new technologies and their synergies. From rigging from TV shows like The Flash and contributing to 3D Bitmoji development and virtual concert setups, his journey reflects the dedication to innovation and collaboration in the ever-evolving landscape of AI and entertainment technology. Juan, could you share what you do at Zero Space and share how rigging has evolved from when you started to how it's used to where it leverages deep learning today?
Yeah. Hello, everyone. My name is Juan Carlos. I go by JC sometimes. So if you see me around, if someone says JC, then you know it's me. What I want to just talk about is just the evolution of AI, but as well as what I do at Zero Space. So Zero Space is a virtual production company in Brooklyn, New York. They really utilize like the latest technologies. They have like we talked about, a markerless motion capture system. They also carry like top tier motion capture systems like Vicon. They have a LED wall, a huge LED wall. They use all types of new technologies and try to put together productions for different types of clients. What makes it unique, I'd say, would be that with traditional pipelines, like for movies or film commercials, you usually have a structured pipeline that has been fine-tuned. Similar to what we were talking about with fine-tuning, machine learning models. It's fine-tuned, it works exactly what you want. You're expecting similar results each time, but what makes Zero Space unique is that it's always evolving. It takes new technology and it says, let's take this one and see what we get. So there's always a unique pipeline that has to be established based on different kinds of needs. And in terms of rigging, when I first started, and just in case other viewers don't understand what rigging is, it's when you pretty much you're building a skeleton template for a digital avatar or digital character or creature. Earlier on in my career, what it was just mainly just if there was like a little movie, like a Barbie movie or a different kind of avatar, you would require to assemble a rig, and then you'd build controllers on it. So then the animator could make the fingers move, the character smile, frown, and that was pretty much the traditional sense, even with television. But I'd say the past like 6 years, it's been more of where you don't really need to build a controller rig to have an animator animated. You're utilizing motion capture, and as you've seen the evolution of motion capture, it's gotten from where you had to wear a suit to now where you don't have to wear a suit. And those things are very important in this industry, just because as more and more artists are getting comfortable with the idea of becoming a digital avatar. The hardest part beforehand was having to put a suit on and taking about an hour to calibrate and getting set up. But nowadays, like just like we did at the NAB demo, any performer can walk into the space and be captured right away, and it's all using AI systems.
Excellent. And I remember you mentioning it only takes like 15 minutes or so to set up the space. So there's not only not the hour plus hassle per person being captured, it only takes 15 minutes to set up the space. That was amazing.
Yeah. So yeah, what's great is that now what we've learned is just because I've worked with a lot of also big musicians like Justin Bieber, The Weeknd, as well as other like just DJs, is that the process of virtualizing someone, or the process of getting someone to move around and then perform in a virtual concert, for example, just takes time, and it has taken time. So it has been a lot of like trying to convince the artist or the performer to get set up. If it's a performer that's comfortable with doing it, it's totally fine. But now being able to just kind of use AI to just get started right away and focus mainly on the performances. It doesn't have to be just singing, but just body capture, facial capture, finger capture, without having to wait to get started. Think of it, it's like dial up. Like, you know, back then at the internet, you had to wait to dial up in order for you to get onto the internet. Now it's more like you're just, you sign on and you're on.
Excellent. Great analogy, JC. Thank you so much.
Yeah, no problem.
So our third panel is Zoom. We met at the Contact and Call Center Expo in 23. Zuyan is the chief scientist at Birch.ai, where he spearheads in research and development of large language model ASR models, that's automatic speech recognition, to automate healthcare call workflows. He is responsible for selecting and designing ML models and data processing, production system architectures, and deployment. With over 10 years experience in speech recognition and natural language processing, Zoom has proven a track record of delivering production-ready systems for tasks such as classification, named entity recognition, and real-time transcription. Zach holds a bachelor's degree from Chasing University in Beijing and a master's degree from Hopkins University, where he worked for the Center for Language and Speech Processing on projects that led to the creation of many open-source NLP and ASR toolkits. By the way, Birch.ai also just announced they got acquired. So congratulations, Zach. That's always exciting when your company gets acquired. So when anyone hears generative AI in a highly regulated industry like medical, everyone's ears perk up. So I'd love to hear, Zach, what you do at Birch.ai and how you leverage deep learning and generative AI, but also how do you navigate the deep learning space in a regulated industry?
Yeah, sure. Thank you. Thanks, Dorian, for having me here. I'm so excited to share experience at Birch.ai. So Birch.ai started, we have the task we want to achieve is we want to help health insurance call centers. There are a lot of agents in healthcare call centers, right? So when we call a healthcare insurance company, we usually the call is handled by some agent, sometimes in the US, sometimes very far away, but they already need to spend a lot of time to handle the call, to keep transcripts, and then to write notes. And then they also need to report to different regulatory agencies like FDA, and they also report to their managers. So they have a really long workflow and pipeline in their daily job. So our mission is we want to build tools and softwares to help them to automate this workflow and pipeline so they can save their time and also have a better experience in working with the customers. So the customers will also have a better experience in the long run. So that's our mission and goal. And in the past 3 or 4 years, we built different solutions starting from the automatic ASR system, which is a transcription. But we have already have some cloud-based solutions like Azure on Google Cloud, AWS as well. But our solution aims to provide not only streaming, but also we can deploy our solutions into customers' internal cloud and on-prem data centers. So that's our and that's the first stage. for SPSR system. And then we also have we also build solutions like use large language models, which is we have a spectrum of different large language models, so that that model can help agents to write better notes after the taking the call, so they don't need to write them manually by themselves. And then the model can handle taking care of writing the notes and summarizing all the important points, and then even format the notes into some specific format to fill into some downstream tools. We also have that's a we call it on-call help. We also have after call analytics, which is like we analyze all the calls like from previous window of time, so that the managers and directors and the analysts they can understand what happens during the past period of time without any help and in a very timely fashion. So yeah, that's basically what we do at Birch.ai, that we offer these solutions to our customers, big companies, big health insurance companies, so they can build our tools inside their internal softwares to make it better to work with their agents to in their like call centers. Yeah. So back to the questions from Darren. Yeah.
Yes, yes. And the question was, in terms of given that you're a regulated industry, how did you navigate it dealing with a generative AI solution in a regulated industry?
Yeah, so that's quite challenging. I had to admit. So that's because with all these customers, high insurance companies we work with, they always have a very strict regulatory rules to follow, like HIPAA, high trust. So with their PII data, which is understandable because those are like data from patient, and they keep it very strict. So we have to work with them yearly. The difficulties come from two parts. The first part is we have to first establish we call a BAA, that a business associate agreement with our customers, so that we share the responsibility and liability in handling their data. So that puts a requirement on our own infra as well, even at the POC part. So we have to make sure our infra also follows the security auditing, like SOC 2 Type 2. So we build a very strict security measurements on our infra first before we taking their data, even with POC. And then with the POC period, we have sometimes we work internally in their infra, in their cloud, to build our tools, ship it to their machines, work with their IT teams. So that's a lot of collaborations and back and forth with their like internal teams. But that's how this industry works. So yeah.
So formal commitment from both to protect the privacy, and a lot of hard work focusing on every detail. Gotcha.
Yeah.
Excellent.
Yeah.
Very good. So at this time, we're ready for our general panel and general questions. We'll dive into our first one in terms of getting started. And we'll start with, let's start with JC. Considering how quickly AI has evolved, do you see yourself using more AI tools when developing avatar production?
Yeah, thank you so much for bringing that up. So recently, there's just been a big boom now with AI applications that are just so easy to use on your phone. Like before, it was like you had to be in an office, you had to be somewhere there's some kind of rig. But now that it's all phone based, I've been using a lot of those kinds of systems. Recently, I was just in Colombia for about 3 weeks, and I started prototyping. I was using this software called Wonder Dynamics. It just got acquired by Autodesk. And what it does is that you feed it a video feed, and then what it does is it finds the avatar, finds the performer, copies the way that they move, blurs them out of the shot, and now you have a digital avatar doing exactly what they're doing. And part of my testing was using drones. Like I had a couple of drones that I was flying out and capturing very, very unique kinds of animations. And what was great about it was just trying to mix different kind of camera systems with AI. What I was finding out was that the more and more that we are using AI with these avatar systems, or the more we're using AI with different kinds of cameras, you're going to find probably the most unique storytelling we've ever seen in a while. Just because it feels like before everything was handled by having someone hold the camera, move here, move there, but just even the camera systems themselves, the way that they behave, the way that they track individuals, that camera system, you're going to find a lot of unique stuff. So I definitely see it being used. I think you have to, part of this industry is you kind of have to evolve with it. Even if you started in one particular place in the industry and this became the standard, as you see the evolution of stuff, you take a little bit of that and you say, how do I mix something that's very new with something that I've already done? And then that's the birth of something else that comes out of it, which is fascinating.
That's fascinating. It's even better when they work together without a lot of problem integrating them.
Yeah,
I think
well, now
at some point you have an integration issue that might be a few headaches.
So my experience is that AI or avatar systems or motion capture systems have gotten way easier, that it's now more of a broad consumer product that people can use. People can use these applications to make their stuff. But what I would love to say about people that have been doing it in a while is that you learn the fundamentals. You learned what it is, the structure that these new AI systems are actually replicating. And once you understand like the fundamental structures, then it's really easy to implement anything, because you know that this AI system is going to try to track a certain kind of behavior. So by understanding what it is that it's doing, you're really able to kind of fine tune those things. And that's kind of where I've done a lot of heavy studying, is like, if I put on a suit for motion capture and I track it, and then I use an AI system to do the same, what are the differences I'm going to see, and what are the differences that the AI system is going to try to replicate from this one?
Excellent.
I love it. It's very, very fascinating.
I find that that's true though, in all, because I know advising people in artificial intelligence, when they don't understand the math underneath it, they'll try to create learning models for the exceptions, which is not how math works. So it's always, you're correct. The more you understand how it works fundamentally, the better it'll be with using it. So our next question is for Omer. Did you have trouble getting data to train your models, and where'd you get it?
Yeah, so actually, that's a good question. Fortunately, one of the biggest advantages of Pixellot is that it has access to huge amounts of data, because we have thousands of systems spread all over the world in multiple sports. So when we want to train a model, to evaluate the model, we take events from different locations, from different installations. Yeah, we have low installations, high installation, from daytime, nighttime. We try to make it as diverse as possible. And we take all of this real data, and on top of it, we apply all sorts of augmentations in order to make the models more robust. And we find that it's very, very effective. And that's how we train the first models. And after it's being released, we maintain those. Yeah, we make sure that we take additional data, we monitor the models, we understand where it needs to be improved, and that way we continue to improve it and to make sure that it behaves the same way that we expected.
Excellent. It's exciting because there definitely is a lot of data, and sports coverage is so much more enjoyable than it used to be. And you can tell, even if you just watch the NFL, the different stations that broadcast it, some have better coverage than other in terms of how they're using the technology. And I remember watching one game, and you're like, wow, I wish they'd get some AI in their tech, because it really wasn't giving you the type of show that you're accustomed to on other stations. So hopefully you'll get more customers too in the broadcast space. So the next question I have for you too, what criteria do you use in selecting one type of model over the other, and how do you weigh them?
So since we're running on edge hardware, so first of all, we take into account the computational resources that the model will require. and also the inference time, because not only run on the edge, we need to run in real time. So these are like two real crucial factors for us. These are the ones that's especially important for the auto production. When I'm talking about highlights and analytics, that way we can have a bit more of margins. Yeah, we can run it on the cloud as well, but for the auto production, we run on the edge. So these are the main criteria. And afterwards, it basically depends on the purpose of the model, how we weight. In most cases, we measure precision, we measure recall, F1 scores, all of these metrics that we just modify it based on the activity itself. So it can vary from object detection to tracking to classification in the frame of the scene and so on.
Excellent. Thank you so much. That's fascinating. Zach, I have the next question for you. What measure of success did you use on the models when you were selecting models?
Yeah, I mean, the end goal is to make customers happy, right? So we actually have human in the loop. As in the end goal is we work with customers, we show them the results, and then they said, okay, we are satisfied. So they have a spectrum of different stakeholders from different departments, like their frontline agents and agents managers, and they also have people from the back office who do the analytics and who run the other tasks as well. So we will work with a group of different stakeholders, and then they will evaluate our results and say, okay, that's what we want, and then that's our end goal for success. Yeah.
Actually, I'm imagining almost like an eyeglass appointment. Do you like this model or do you like this model?
Yeah, definitely. So you already need to run several iterations. Yeah, that's
Got it. So once you have it narrowed down to all of them that you can accept, you then ask them to fine tune and pick the final. That's fantastic.
That's why we fine tune this.
And I'll get the next question for you, Zach, as well. Do you have any adoption challenges?
Oh yeah, that's a good question. So we at first for several years that before the come out of GPT-3, it was many people just don't understand how this thing can work, and they don't even believe that our thing can achieve what we told them. And after they try GPT-3 and they try with some other tasks, they say, okay, this stuff can actually work, and then we want this in our work as well. So that's sometimes that helps us narrow the gap between the understanding and the adoption of people in that industry. But still there are a lot of people they don't believe that the large language model can achieve and can help them in very complicated daily jobs. Yeah, that still happens sometimes, but things get better and better. Yeah.
That's fascinating. So it took the public release of ChatGPT and everyone using it to understand that it could be done. It was amazing because I was at NAB show in 2023, which was soon after ChatGPT was very public. And obviously in video and motion capture and sports streaming, they've been using deep learning and generative, to do the highlights and such. And so it's been used for a long time, as anyone who's in AI knows that, but it's just come to the public recognition of the technology. So I'm glad the public recognition has made it easier for your product to succeed. You would think when they see it working that they would understand it, but it's nothing like when you can touch it yourself. So understand that. So our next question is for JC. How has the development of AI changed the scope of motion capture in your field?
Great question. I also want to just point out that it's very nice to get a chance to talk to everyone here. I find it fascinating, both your just kind of like things that you guys are discussing and breaking down, which is really fascinating about AI. You can be specialized in one location, but as you look around, everyone has something very, very unique. Yeah, in terms of the question that you asked about how AI has changed motion capture, it's changed it tremendously. I would love to just maybe give out an example. Would be in 2019, I was working for a company called Wave XR, and what we did was virtual concerts. So this was right before the pandemic, and then the pandemic happened, and there was like no one was outside, no one was doing any kind of thing because everyone was staying indoors. So you had to find a unique way of still entertaining people, but also musicians still being able to tour, still being able to perform. And that's where I think virtual concerts really shine, because you could do it in a confined space and then broadcast it in a way where people felt immersed. When we first started off, it was, for example, it'd be someone like Lindsey Sterling or John Legend would get in a motion capture suit. At that time, it was one called XSens, which used like little sensors. And it would take about maybe 30 minutes, 45 minutes, really just to kind of get them in there, then training people to say, this is how you perform in a virtual space. Which was very exciting to see. And then a few years after that, after things kind of settled down, and I'd say like 2 years ago, there was the introduction of a markerless system, and right now there's tons of markerless systems, but we started using one in particular. And based on our experiences was when we started tracking higher tier performers, it was very hard for us to get them or to convince them really to put on a tight suit and perform in front of people in a very like uncomfortable way. So when we started using AI systems that required no suit, we noticed very quickly that people would be able to come in, perform, and leave. It reduced the amount of strain on even the company because the pressure of trying to convince an artist to get in the suit, to get calibrated. If something goes wrong with the suit, what happens next? So now it's a lot easier. They get in, they're in front of a room with, like, let's say 12 cameras. It tracks every angle from them, and it can detect fingers, it can detect face. And you get started right away, and then it becomes more about the performance. It just changed the scope now, where now it's more about capturing the moment, similar to sports, similar to what you're saying. It's like that moment that if you can capture that moment, or maybe that goal that somebody kicked in that you don't know whether or not it went in or not, but you're using AI, and you're like, oh my God, it's about a millisecond, and it's actually, and it's a goal. So we're learning that these AI tools are, as much as people might want to feel like intimidated about the changing of it, it's actually also ways of allowing us to just kind of enjoy the other aspects of sports, technology, anything else like that, and really just feel more embraced in the moment.
So the startup burden is gone. You just get to enjoy the fun of using the tech.
Yeah, it is, and it's fun. What's great about it is that it allows you just to kind of enjoy other aspects of your life. As much as we're passionate about what we do, we also have our lives. Some of us might have families, some of us might want to enjoy other things, but it's nice to see that technology it's a very positive thing when you use it right. And I feel like as people that use AI, we need to find good examples to show the majority of the public how you can use AI in positive ways.
Excellent. Great point. Our next question is for Omer. How do you handle the challenge of AI models on production in practice?
Yeah, so I guess that maybe some of the audience it will come as a surprise to them, but we know that our AI models will not always get it right. We know that eventually every model will have mistakes on production. It can behave beautifully. When you develop it, you can reach like a maximum percentage of every metric, but at the end you will have surprises on production. So and especially if you work in like we do in real time and on the edge. So our goal is not necessarily to make perfect models. Sometimes we do, yeah, but it's not necessarily our goal. Our goal is to make a perfect production, okay? And it's different because the production is built on top of several models, and that's a very important concept that you build the products to have like compensation.